Hello, everyone. I'm Dion Cook from AVIXA, and welcome to LED Video Wall Technology, a peek under the hood, hosted by Sander Baez with moderation from Alina Mishra. This webinar is brought to you by today's sponsor, Barco. Before I hand the presentation over to the team at Barco, I need to go over a couple of quick housekeeping items. For everyone viewing today live, the webinar qualifies for a half CTS, CTSD, and CTSI RU. Please allow up to 7 business days to view those on your transcripts. If you have any issues, please email the AVIXA team directly at webinars@avixa.org. The webinar should last approximately 40 to 60 minutes, and all attendees have been placed on mute. If you have any questions during the presentation, please enter them into the Q&A window so today's moderators can address them at the end of the webinar. To access the Q&A window, simply move your cursor towards the bottom of the screen where you'll see the Q&A icon and type your message there. But be careful not to put your important questions in the chat box, which is a couple of icons over from that. You'll have access to this recorded webinar on our website at avixa.org/webinars within about 7 business days or so. Now over to the Barco team. Please take it away.
Yeah, thank you, Diane. To all people who joined the call, also thank you very much. And thanks for the opportunity to AVIXA as well to hold this webinar. First of all, my name is Sander Baez, as mentioned by Diane, and I'm the product manager LED for Barco. This is the second webinar that we're doing on LED. The first one, I think, was already going pretty deep into LED technology, but there were some people who wanted to learn even more. So today we're gonna address those things. We're gonna really go deeper into the core of LED technology. As you can see, I'm working from Belgium. So I'm currently in the headquarters, the building that you see on the first slide, on my title slide. That's actually where I'm located right now. And you can also see this behind me. So that's the curvature of that round building there. I think before we start, can we maybe bring up a poll to get a first question out to you guys? So I think that's stabilizing. So 1/3 of the people who joining today have done an LED project the last 3 months. So I assume there's quite some veterans in this webinar that know quite a lot about LED. So I hope at least I can shed some light on a couple of things and that you learn a couple of things as well. For those who are not that familiar with LED, welcome as well, of course. And I'll make sure it's interesting for everybody. So to start off with, yeah, the evolution of LED, this is actually something that my colleague Todd already talked about. I'm gonna not spend too much time on this, but just want to point out that as Barco, we've been around from the early beginning when LED technology was emerging. So prior to 2000, we had the true hole LEDs, which were predominantly used in outdoor applications. And there's even still today a couple of displays of Barco LED displays at Times Square, New York, for example, just to give you an idea how far back we go. The evolution went to the 3-in-1 SMD LED packages, first white, but as the LEDs became more efficient, we actually could use black-faced SMDs. Later on, because of the smaller pixel pitches, we needed to move to yet another technology, which is referred to as chip LED. And actually, it's quite similar to SMDs with the big difference, the manufacturing process. I'm going to explain a little bit more on that later on during this webinar. One of the latest developments is chip on board. Chip on board is a totally different technology. Different technology when you consider the way the LEDs or the diodes are placed onto the LED board. And there's also the 4-in-1 packaged LED, which is actually a transitional technology between the traditional SMD packaged LED and chip on board. What are mini LEDs and micro LEDs, two words that or questions that I get a lot. What's the difference? And when I was thinking about an explanation, it actually dawned to me that there's a little bit more buzzwords that are flying around today in the realm of direct to LED technology. So as you can see, there's quite a lot. There's chip LED, COB, wire bonded, IMD, SMD, flip chip, 4-in-1, TH, and so on. So it's quite confusing, and more specifically because these words are used also not always in the right context and with the right meaning within that context. So first of all, if you really would make a deviation on the different products that are in the market, then you can make one big distinction between the main technology that has been used. So I mentioned already TH or DIP, True Hole LEDs. We also have TOB, chip on board, and SMD. Because TH, the true holes, is something really from the past, and even outdoor displays today don't use it anymore. I'm just going to toss that away, make life a little bit simpler. IMD and 4-in-1 are actually referring to the exact same thing, so that's also out of our way. And then if we reorganize it a little bit according to the actual meaning of the things, it also becomes a little bit more clear, I hope. Now, I'm going to explain what all of these things exactly refer to. First of all, COB or SMD, so chip on board and SMD, surface mounted diodes. That's the chip placement on the board, the way how that's done. And like I said, I'm gonna really go into depth about the differences in the next couple of slides. Then the pixel packaging process. We talk about packaged LEDs and chip LEDs. When we make a distinction on the chip connection, we have flip chip or wire bonded. And then the size of the diodes, we have mini LED and micro LED. So first of all, by the way, a couple of examples. A product can be a chip on board product using flip chip connections and using mini LEDs. A product can also be SMD, flip chip using mini LEDs. There's products like that in the market. And there's also SMDs using chip LED, using wire bonded LEDs. Another example of something that cannot happen is, so you cannot have a flip chip and a wire bonded at the same time because they are both referring to the chip connection. A little bit of explanation then. So the size of the chip, that's pretty straightforward. Let's start off easy. So a diode, depending on the size, we will talk about LED, mini LED, or micro LED. And there's thresholds, so anything below 100 micrometer is actually worth of the name, worthy of the name micro LED. Now, in a lot of marketing collateral, this term has been used sometimes incorrectly. Sometimes it's used to refer to chip on board, or sometimes it's used to flip chip SMDs. But actually, if you consider really the meaning, the size of the diode, there's a lot of misnamed products with the name micro LED in the market. Next is then the chip placement on the main circuit board. So the big difference between chip on board and SMD, with chip on board, the diodes are placed directly onto the LED board. With an SMD surface mounted device, this is happening with an extra step. So first, all the diodes are packed or packaged together in a small assembly like mini components, and then all those packages are stuffed separately onto the main LED board. So there's one extra step in the manufacturing process, and that's also one of the reasons that chip on board is one of the advantages, let's say, of chip on board. Now, before I continue, I also want to point out that every technology has its own distinct advantages. So depending on the application and depending on the situation, one technology might still have a preference above the other one. So it's not by definition, for example, that the most expensive product is in any situation the best choice. For example, if we consider chip on board, the diodes are placed directly onto the LED module. So these also need to be protected with a coating on the level of the complete module. And this makes these products generally very reflective. So you could say we're gonna make that coating less reflective, and then of course you're sacrificing some of the contrast. So the blackness of there's a trade-off between the blackness of the LED wall. So it really depends on the application and the use case, which technology is the best choice. So another distinction, so I talked about this packaged LEDs and chip LEDs, both are very similar. So they all talk about a small package containing the three diodes, RG and B. But with a packaged LED, the RGB chips are mounted into a molded package, and afterwards the package is then filled with a clear silicon. Whereas if you consider the chip LED, you have the multiple RGB chips are placed simultaneously, if you want, on a substrate, and then they are overmolded with clear epoxy and then cut in a process which we call dicing. So why would you use one over the other? Well, it has to do with the pixel pitch. So for those familiar with LED, you know exactly what I mean. But a pixel pitch, as it's in the name, it's the distance between the centers of two neighboring pixels, between the centers of those pixels. So as a general rule, you could consider that within the industry, anything below 2 millimeter pixel pitch is using chip LED instead of the packaged LED. The space on the LED board is just so small that it's becoming very hard to put those packaged LEDs on the LED board. So they're usually also larger in size. I put the picture here just for you to remember the next time if you see an LED wall. Well, there's a big difference. You have this is a white-faced packaged SMD, by the way, but you can clearly see that this looks different from the chip LEDs on the right. So next time you will be immediately able to tell what kind of product it is just by looking at it. Then the chip placement can be wire bonded. That's the traditional way of doing it, or it can use flip chips. Now flip chip can be both COB or SMD. There's actually a product that's using a flip chip, but one of the downsides is that they also use a coating. In theory, this is not completely necessary, but there's still also some optimization to be done in the manufacturing process for flip chips. So currently, they're also facing the same. I think, well, in some cases it's a problem, but the fact that you have to put a coating on the complete LED module. Then the last one, mini LED, it can have different meanings. So actually, the true meaning should be referring to the size of the pixels or the diodes. Sorry, not the pixels, but the diodes themselves. But within the LED industry, it's also a lot of times referred used to refer to the 4-in-1 packaged LED. So like I said, what is the advantage of the packaged or the 4-in-1 package? It's that you have less pick and place steps during the manufacturing process. So it's cheaper to manufacture. It could be more robust, but on the other hand, if you have a malfunction or a defective LED, it's usually always a cluster of 4 pixels. Well, not always, but it could be a cluster of 4 pixels. So this could also be more visible. So also to conclude over here, every technology has its advantages. For example, if you look at the IMD and have a picture there, if you're really too close to the LED wall, you can start seeing that additional grid of the 4-in-1 pixel. If you're at a fair distance of the display, there's really no real disadvantages of the IND as compared to the normal chip LEDs, where you have only one pixel per package. So that was a little bit of background. I hope that cleared some of the buzzwords that are flying around, or give it a little bit more meaning when you're in a conversation next time on one of these topics. Next thing, so I'm gonna really zoom in a couple of real applications. Currently with Barco, we are focusing on narrow pixel pitch products, but not just any narrow pixel pitch applications. Usually it's the ones that require some more attention in the image processing or in the reliability of the product or the color gamut and etc. So I'm going to talk a little bit about what are the problems and what could be done to solve those problems in this particular environment. So this is a picture. It's not in a television studio, but it's a nice example where you don't have the proper lighting, and this is a presenter in front of an LED wall. I think it's at Infocom or ISD. Anyway, you can see it's at a show, and yeah, the problem is, of course, that the presenter is underexposed, and the reason is pretty logically, I think, you have to fight the light of the backlight of the LED with some front light on the presenter. That's one way of doing it. The other option would be to dim the wall. And here's the problem. Not all LED walls perform as well when dimmed. It can introduce a lot of different side effects like flickering or decolorization or loss of bit depth. And it's about loss of bit depth that I am going to try to explain this, and it's the first time that I'm actually going to try to explain it for people who I suppose not everybody will be that familiar with it. Oh, should I forget to mention, before we continue, I have another poll question, so maybe you can bring that one up, or it's already done. Oh, there it is. So I'm pretty much liking what I'm seeing in the responses of the polls. So I hope this reflects how most people in the industry are thinking. So image quality is still very important. I know not all types of applications pay equally as much attention to image quality, but this is really the biggest strength of Barco. It's where we really put most of our effort at. Now, I also have to say that ease of installation and servicing is one of also of the main things that we have been working on, at least for the last 5 years, to make that process as easy and predictable as possible, and definitely also servicing. So it's very good to know that we're addressing a lot of people's concerns in the LED industry or in the Pro AV industry. Um, so yeah, I was going to talk about the problems that LED walls have with dimming. And by the way, dimming is not only important in broadcast; it's also important in other markets like control rooms, etc. So first of all, poor processing can result in loss of color bit depth when dimming. I don't know if this resonates with everybody, so I'm going to try to explain it. So if you look at the background here, and this is of course simulated, and check again right now. So this is what can happen when you're dimming and when you have a bad processor for your LEDs. So you get these grains of contouring, which make your display look like it's coming back from the 80s, I think. That's how I remember our displays when I was a kid. But why is that? If you consider that the color bit depth of a source is usually 8, or in the case of in the HDR, 10 or 12 bits, well, 12 bit is already quite exceptional to be honest, but it exists, then why do we find on the spec sheets often things like 14, 16, 18, or 23 bits? I'm going to try to explain that. So, first of all, we have bit depth can have different meanings depending on what we are referring to for a display. So we have the bit of the colors, the bit depth of the colors, which is usually 10 bits or 8 or 12. And these are the visual consistent increments in brightness that we can perceive. So if you have an image, a picture, which is 10 bits, then let's say if the color is white, then this pixel can have 1024 brightness levels to depict a specific color. And the other thing that you find sometimes is the 16-bit, sometimes it's called dimming, but that's actually referring to the electronic brightness increments. That's the driver which is using PWM. You don't have to really understand what that actually means, but just know that the 16-bit and the 65,000 steps is referring to brightness increments, not visual increments, but brightness increments electronically. So you could already ask, yeah, but if my source has only 1024 uh, visual steps, why would I need 65,000? That's the question that I'm going to try to answer right now. And even then, we have the processing bits, which is then actually also referring to brightness increments, but these are not solved purely electronically, but in the processing. So first of all, I'm going to explain with a very simplified example. This is a 3-bit gray ramp. This is not what modern day displays work at, but it's just for the sake of the example. So we can clearly see in a 3-bit gray ramp that we have 8 visually equal increments. What do I mean with that? If we would consider the jump in brightness from this one, from the second square to the third, it should be almost perceptual equal to the third and the fourth. So visually equal increments. Now, if you would have an LED wall, try to put it, just do this as an experiment. If you have an LED wall somewhere where you can play around with and you have control over the brightness, I challenge you to put it on, let's say, 50 nits and 100 nits, or 100 and 200 nits, and then to 900 and 1000 nits. You'll notice that the difference between 100 and 200 is much bigger than 900 and 1000. And there's a reason for that. So if we look at the brightness increment, so our eyes are less sensitive to highlights, to whites. So we need to jump in larger brightness increments as we get closer to whites. So this is as an illustration. If we make one jump in brightness from the first to the second, we need to make 3 jumps to go from the second to the third, and we need to make 8 jumps from the eighth to the fourth, and so on. So you see that as closer we get to the white, the bigger jumps in brightness increments we need. These numbers are just illustrative, but I chose them in such a way that, of course, this was leading up to 256 increments that I should need in my display to properly show a gray ramp, which is going smoothly from black to white. So that's the first thing you should remember. So the bit depth of the video is not the same as the bit depth for the display. And then the darkest tone of gray is the smallest step, the one there, and that's usually a fixed thing. That's a fixed number, and it's determined by the maximum brightness and by the bit depth of your driver. Okay, so let's see what happens when we're going to dim this. So continuing on this 8-bit, what do I say? 8-bit. It's on this 3-bit gray ramp with 8 shades of gray. So this is at 100% brightness. So what happens if we dim it to 50% brightness? Well, the most or the brightest square is actually the one in the middle of the first one. So if we step back with equal increments to the black, well, then you'll notice that there's quite a lot of steps that we are missing, specifically in those darker areas. So we lose that information when we are dimming to 50% brightness. And if we would even go further than that, 25%, we lose even more information. So it's very important. So this would happen if we would do nothing in the processing and just rely on our um, driver pulse width modulation bits. So what is now the point of my story? And this is coming to an end. For 10 and 12-bit video sources as used in HDR, we actually need 23 bits of processing in order to not lose details when we dim and showing contouring in the process. Also, be aware that contouring is more prominent, it's more visually present if we use synthetic content. What do I mean with synthetic content? Typically, the computer generated content. You have clearer bands going from one shade of gray to the next one. Other problems in broadcast are moire, and actually the dimming has also a positive impact on moire. Why? Because we can use a larger aperture, and because of that, we have a little bit more flexibility in our setup, how close is our presenter to the display, because that's also impacting moire. There's a lot of different stuff impacting moire. Looking at LED in control rooms, what are the problems there with LED? Because LED has been around already for quite some time. It's not, well, it's starting to enter more and more into the control room market. As you know, Barco is traditionally using RPCs or real projection tubes or LCDs for control rooms. But because we have such good performance in low brightness, we can definitely in narrow pixel pitch also use our LEDs in that environment. Plus, we have multiple failover systems, which make sure that the uptime is secured of the LED display. Now, one of the problems as we dim the LED wall, which is in a lot of times the case, the flickering, the scanning effects become more prominent. But that's for the next slide. First of all, some of the visual distortions that can occur, and this is an actual picture I took from an LED wall I came across. This is a phenomenon called cross-coupling. Problem is that this is impacting your image with a vertical line. So we don't want to have those kind of artifacts in the image. The next one is an example of tearing, which can occur in between two sections of the display, which are driven by different image processors. So LED is a modular system, so we can easily exceed the capacity of one processor. So it's very important that the different processors work well together. And of course, with Infinipix, which is the controller driving all Barco LED products, we have that perfectly well under control using fixed delay. Another thing, this is purely mechanical. If that grid, and this is even not talking about seams, because you also have seams, of course. This is due to the fact that this product was using too thin PCBs for the LED boards without the stiffener. So if you have light dropping on the LED wall, you actually can have this kind of grid-like mechanical artifact. The other thing I mentioned already was flickering, and this effect becomes more prominent on most LED walls as you are dimming the LED wall when you're not putting it at 100% brightness. And believe me, you never want to put the LED wall at 100% brightness during in a control room environment. So at Barco, we have also there looked what can we do. So we implemented the patented driver algorithm to reduce the flickering effect of the LED wall in a dim state. And this is then actually my last slide. This is an example of a totally different application. And I just wanted to point out that, okay, I've been talking about LED during this webinar, but Barco is also specifically, especially for the target markets that we are more targeting or more active at, and specifically in broadcast and control rooms and like a workplace where we have meeting rooms and experience centers, lobbies, auditoria. We don't have just a display, we have actually a complete end-to-end solution for that, which is not only interesting because we have a complete system that has been tested in a current setup with optimal latency, for example, which can be interesting when you have a presenter in front of a wall. But also, for example, this is for a meeting room. So because we have that complete chain of video in our hands, we make sure that there's no incompatibility issues with resolutions or frame rates. Everything is supported. We can even have very advanced scalers. So we can put in any resolution. Actually, we can even put an HD resolution or 4K display. It will look as crisp, almost as crisp as it would have been a native LED wall. If you don't believe me, I'll invite you to have a talk with our people at image processing from the E2, for example. So I'm at the end of my talk. I hope it was a little bit interesting. I hope you learned a couple of things about LED and also about Barco. Maybe not all of you were aware that we do more than click share or more than cinema projection. That we actually are also pioneers in LED technology. And before we go to the Q&A, I would like to also launch a couple of polls, and then we'll have a look at the question. So what's the first poll? It's what's the main application that comes to your mind when you hear Barco? I'm very curious about that one. This is really interesting. So indeed, a lot of people know us from ClickShare. And to be honest, because yeah, the cinema projection, like we are market leader in cinema projectors, but even in Belgium, there's not a lot of people that know when they go to the theaters that the projector is actually running with a projector of Barco. For example, also it's not only Barco projectors, but like for example, the light engine in the IMAX theaters is also Barco technology and such. Healthcare displays, nice. Okay, cool. Then another question, would you describe your role as a V, IT, or both? A lot of IV people, a lot of both. Cool. Okay. I think that this was the last question or the last polling question. Should we jump to the Q&A? Thoughts?
Hello, everybody. So thanks a lot for all the questions, all the answers that I see. I see a few questions already popping up on the chat box. And I'm going to start reading those out to you, Sander. But in the meanwhile, if you have questions on what was presented today or anything else in general related to LED that we can hopefully answer, put it out on the Q&A box. But let me color some of the main things that I see here. I think a lot of these questions are okay. Sander, first one from Mark. Any plans for Barco to offer a DCI compliant display?
DCI compliant LED display, I think they mean it. I know that LED has been entering the market with Samsung. Currently, it's something that we are investigating, but currently, I think projection is still the better option. As I know, I mentioned already, there's also some issues with LED. It has a lot of points of failure, and we are also considering the exhibitors for theaters. And also, LED still struggles with really hitting the targets for 2020. So for the time being, when technology is let's say really a competitor for let's say the laser projectors that are currently dominating the theater industry, at that time we will make our stand, I think. But currently, it's there's no real plans to do that yet, as we noticed that it's still for the majority all projector driven.
Okay, next question from John. Where do you see pricing for DV LED going over the next 1 to 3 years?
It's a very interesting question. So if you would read the market reports, then there has been a stagnation predicted already for 2 years, that the prices won't drop that much anymore because suppliers of LEDs have been squeezed out, and there's not that much gains anymore on production process. But in reality, we noticed that there's still quite a big price erosion that was contradicting the market reports. So that's I think a little bit harder to predict. I think rather than that the price erosion will probably at some point hit the saturation. But then I think maybe there will be other and new technologies that have more advantages in the direct view LED realm that will be very expensive at the start, and then again you will get price erosion starting in those technologies. But currently there's still some price drops every year, but it's not as aggressive, definitely not as aggressive as let's say 5 years ago. So I think in that regard, investing in an LED wall becomes more safe, let's say, from an investment point of view.
Next question from Aaron. Any advantages to curved LED displays?
To what LED displays?
To curved LED display.
Advantages. Well, if you have small curves, if you need to make tight curves, then you really need to have a flexible product, or you get a segmented or a faceted curve. So for those applications that really require small radius, there's an advantage. On the other hand, it's also harder to get to smaller pixel pitches, so there's a physical limitation there. But for the market that we are active in, actually the radius and the diameters are so large that there's really no big advantage to go for a really curved module. So it's also going to be faceted, and it has the advantage that it's easier to service. So for large setups or large curves, like in control rooms and usually in broadcast as well, there's not really a big advantage over curved, aside from maybe slightly aesthetically. But if you can then consider the reliability and the servicing options, then I think a faceted curve for those large curves is still the better choice.
Next question from Edward. How are you dealing with the calibration of your walls on site?
Yeah, so first of all, the calibration usually happens in the factory, and there's different manufacturers use different methods of calibration. Some manufacturers just build the wall completely in the factory acceptance test, and they will calibrate it on the entire wall level. And this might look good, but this also has the risk that there might be a slight gradient which is invisible from left to right, for example. And what's the problem there? If you replace the module in the middle of the LED wall, this can be this can be visible if, you, for example, you put the entire LED wall on a solid color, like solid blue, solid green, solid white. So the way how we do it at Barco, we calibrate all the LED modules individually. So it doesn't matter. You can swap the LED modules around if needed, at least from the color performance point of view and the uniformity. This won't have an impact. Now to come back to the question, because this is a question I got a lot. What happens if you have the LED wall operating for, let's say, 5 or more years, and you replace the module? So first of all, the module needs to be from the same batch. That's a given. But still, there is some aging going on. First of all, what we do in the factory is we age the biggest part of the LED walls already in the factory. If you look at the aging curve, the LED becomes stable after, let's say, a couple of days. So before we even measure the calibration data, we already go to the worst portion of the aging. After that, the LEDs are pretty stable. They will still age and degrade, but far less aggressively. Now, in the case that you replace an LED wall after 5 years, also consider that we are using pulse width modulation and we're rarely putting the screen on full brightness. So the aging, it really occurs only in one color of the RGB, which causes the uniformity issues. In that particular case, at least with Barco, we can do in the field calibrations to really measure the whole thing at once. So this also means that we're not going to do it on the module level, but then we're doing it also like most other manufacturers on the complete wall level. But that's in the worst case where you have some degradation, let's say, of the epoxy of the lenses of the LED.
I think there's an add-on to this question from Paris. Does Barco have its own calibration tech for LEDs? I guess calibration technology, like an in-house technology for LEDs. That's how I understand it.
Yeah. So we have our own calibration method. There's different systems like Radiant and so on. But it's really let's say, how do you make your calibration uniform and how do you reach the wider color gamut? Because usually, like if you compare it to Rec 709, if you have really premium LEDs, you can hit Rec 709 with 100%, which is something that we do with our Core XT series. The XTE series, we have loosened up a little bit the requirements for the individual LEDs in terms of color wavelength. So we have a slightly wider binning. And in that, for those products, we only hit 99% of Rec 709. So why do we see then always people talking about Rec 2020 or DCI-P3 when I say that even with the most premium LEDs, you can hit Rec 709, which is a much smaller color triangle. And the reason is that we also support Rec 2020 and DCI-P3, but it's with the way how we calibrate. And we are using intelligent algorithms, or not algorithms, but intelligent logic. For example, if you're interested in that, look for Macadam. So what it does is it's going to group, for example, if you are in the red, so in the red colors, you have a cloud of different wavelengths. It's going to group wavelengths of which we know from experiment, from scientific research, that are, if you group them together, there is no visible distinction. There is no visible difference that we can perceive. And that's how we really hit very large color gamuts as well, even though the purely on specs, if we would calibrate it to the worst LED, it would be only Rec 709. So In theory, you're sacrificing a little bit of uniformity, but because we do this in a very clever way, and we have color scientists only doing that, and this is completely proprietary to Barco, we can really get very close to the larger color gamuts like Rec 709 and DCI-P3.
Okay, the next question is from Sonia. Thank you for the presentation. Do you expect to have any problems with latency with 8K displays using ClickShare? Greetings from a cable fan.
As far as the LED display is concerned, there's no relation between the size of the LED wall and in terms of resolution, of course, and latency. We have always 3 frames from the source to the actual display when the image is drawn onto the LED wall. And also latency is one of those specs that you should be very careful about. And I think Todd in the previous presentations showed a slow motion recording that I did during a shootout, where it were only premium, I'm not going to name the brands, it were only premium brands which were present, and we were still by far the best in terms of latency. It comes from our history, of course. Not a lot of people know this, but we were actually quite big in the rental applications, let's say 7 years back with our C series. And for live events, of course, latency is very important. So 3 frames from the input source all the way up to the LED wall. And to also give you an idea, we have done also with this kind of products, narrow pixel pitch products, very large setups with live, and I'm talking 30K or more in terms of resolution. It doesn't have any impact on our latency. So as far as ClickShare is concerned, I don't know if there's a difference between 4K and 8K, unfortunately, but it's something that we can check. So let's take that up as an action, and we'll let you know.
Thank you. The next one is from Jivan. SMD, chip on board, any pointers as to how to choose the best technology based on specific applications like lobby signage, boardroom, control room, etc.?
Well, I think a first consideration would be budget. Chip on board tends to be more expensive. Now, there are manufacturers that have within the same product line both chip on board and SMD flip chip, and they look from a distance quite similar, but from up close you can clearly see the difference. Of course, the flip chip SMDs are much cheaper than the real chip on board product. So I'm thinking, if I think about chip on board, I think about the Crystal LED by Sony, which is a nice product, of course. If you have been to Infocom and you've visited the Sony booth, you definitely have seen that. And I think the biggest disadvantage there, and that's also the reason why a lot of the times they try to keep the display away from environmental light dropping in on the LED wall. So I think the biggest disadvantage there is reflection. They also have matte versions with less reflection, but then you're sacrificing a little bit of that contrast. So if reflection is not accepted in your application, I would go for SMD. If reflection is not an issue and you like the shiny finish of an LED wall, that could also be a reason. Then chip on board might be one of the reasons to go for. Also be aware that chip on board might be harder to service. So if there's a defect in the LEDs, you have to cut through the coating. So that's a more delicate process, and it might result in visual artifacts, which is not the case with SMDs. So like mentioned before, both have their advantages. They have their distinct use cases, I think. I think you have to approach it in a case-by-case approach and go from there.
Okay, next question from Phil. Are most displays rated for 24/7? And do you highly recommend using a Barco source scalar processor as opposed to a third party? So 2 parts of the question.
Yeah, definitely for the second part of the question, I definitely recommend to use barcode image processing in combination with our LED wall. First of all, and you might think I'm biased, I know that E2 in combination with our LED wall has tremendous performance in terms of latency, at least for latency. What we have also noticed that if the switcher and the LED wall is coming from a different manufacturer, because of course, if you have another manufacturer, the E2 will also have the same latency and the same performance. But then if there's an issue with, for example, I'm still referring to latency as an example, it's a finger pointing game. Everybody's going to say the problem is with the other component in that video processing chain. And only to avoid that discussion, it's all barcode, so you have to solve it, for example, if there's a problem. And I can guarantee you that I think the ecosystem of event masters it's rock solid in terms of presentation switcher. Also, I'm very confident in our Infinipix image processor. It's been around already for probably 7 years, so it's matured quite a lot and it's very robust. Also, was there another part of the question?
I think you may have touched upon it. Are most displays rated for 24/7?
Oh yeah, 24/7 indeed. I forgot that one. I would say that a lot of LED manufacturers will put it on the spec sheet that it's made for 24/7. I cannot talk for the other manufacturers, but Barco, we take pride, a lot of pride in putting our money where our mouth is. And if we put something in the spec sheet, you can rest assured that it has been tested, and that we, or at least that we definitely also stand by that. And indeed, our products are also suitable for 24/7 applications, like in control rooms. It's one of those in broadcast not, but also in certain lobbies, for example, it might also be 24/7 use case.
Okay, Mark says, with large displays with multiple panels, do you provide spare panels with LEDs from the same batch for perfect color matching?
Yeah, very, very good question. I mean, when you consider service contracts and warranty, there's a difference indeed between having the component warranty and actual having a uniform system warranty. So, in my opinion, if you invest in LED wall and somebody offers you, let's say, an infinite warranty for the lifetime or whatever, to me it's meaningless if it's not mentioned that it also guarantees uniformity. You can replace a module. We can make a new module 5 years from now, but if you would replace that and put it in your wall, you will notice it. It will be visible, and in the end, you end up with a patchwork of different shades of the same kind of color. So it looks ugly. It's not what you buy, what you bought your LED wall for. You want your LED wall to be, in my opinion, always also a nice eye catcher to make whatever you want to do stand out. Um, so first of all, yeah, batch compatibility is very important, and also it's not always clear in the service contracts offered whether this is guaranteed. For Barco, we guarantee batch compatible spare parts in our extended warranty program. It's called Essential Care. We can go up to 7 years with our current product portfolio. But this is, of course, because it's batch dependent, it's something that has to be decided during the actual sales interaction. So it's not something we can add in after 2 years, because what we actually do behind the scenes, we will produce an extra amount of spare parts. So those can be then, we will keep those also at the factory, not at factory, but in our warehouse. So we will manage that stock just to make sure that there's no discussions on, yeah, but you told us that we have enough spares to cover the 7 years, but we want to have also control that. On top of that, we also offer in that same warranty contract, we also offer installation spares to make sure that there's no unexpected delays during the installation. And we also will always put a certain number of spare parts on site to do a quick swap. What else? Yeah, to do the quick swap. And then we don't wait for the defective module to come back at Barco. We will immediately ship out an extra spare the next business day. Of course, the replaced spare part will need to be shipped back to Barco because we will then repair that and put it back in our stock for to make sure that you have enough spare modules for the duration of the contract.
Perfect. Next question. It's more of an example, so I'm going to describe it for you. He compares two brands, one being Barco. So a brand X, which is 1.2 pixel pitch, 110 diagonal versus Barco 1.2 pixel pitch and 110 diagonal. Even though the spec remains the same, image quality vastly differs. What is the major reason?
The major reason for image quality is the selection of components for one. So like I said, there's different types of LEDs, but even within the same, well, people tend to say, well, you have a Nation Star LED or a Harvatech LED, so it has to be a good one or a bad one. That's really not the case. But even within the same brand, you have LEDs that are 10 times cheaper than other ones. And the reason why is because LEDs are produced in great numbers. Let's say we have a production of 200 2 million blue diodes of, let's say, 1 million for the sake of the argument. It makes it a little bit easier to calculate. So let's say you have 1 million blue LEDs. Only a small number of those of that production run will have the wavelength that is corresponding to the requirements to meet, let's say, the Rec 709 blue point. So of the 1 million LEDs, we can only use, let's say, 10,000. So if you really want to have that narrow bidding, and it's only one aspect of the LED, of course, because there's also other things, but that's one thing that influences the price. So of the 1 million, you can only use 10,000. So it means that it's a lot more expensive to produce that. So that's one thing. And then the second thing definitely is the image processing. And I think always be careful. I think that's one of the nicest things about our product, I think, is that we have that complete image processing in-house, that we have that development in-house. Todd already gave a couple of examples in his presentation, and I also give one with the cross-coupling of the board. This is things that you will never, ever see in spec sheets. These are poor driver optimizations, and I can give you another example. For example, we have the 0.9 millimeter pixel pitch product. If you look at our spec sheets, you will notice that the refresh rate is 1920 hertz, while all other products in the family are 3840 hertz. So you might say, well, is it then less good than the other ones? Why is it lower? Well, to give you the full story, when we first launched that product, we actually spec'd it also at 3840 hertz. But it's only when we noticed that actually in the low lights we had some problems, and this is not inherent to our product. It's going to be the same with every product with a 0.9 pixel pitch. And you got severe decolorization at a high refresh rate in combination with the banking. So we optimized that so you get a consistent color and a consistent color tone in all brightness levels, but also both in dark areas of your display as the bright ones. And this is just one example of how controlling that complete process has major advantages and a major impact also on the experience, the visual experience that the end user eventually gets. So I would say
we are almost at time. I think I'm going to pick one more question that still leaves close to 10 unanswered questions, Sander. I realize there's a lot of interest around LED. We experienced something similar in our last webinar as well. And just like we did it for the last webinar, everything that we are not able to answer, we will type out the answers for you guys. And when we send out a recap email, we will make sure all of you can access. So as long as we are able to send you an email, you should have an answer for all these questions. But the last question quickly will be, um, will Barco provide an all-in-one series of pre-packaged solutions? That is a 130-inch, 165-inch, 200-inch plus diagonal, 16:10 aspect ratio display for boardroom solutions.
Yeah, we do already have those packages defined, but it's only the LED port. So it's not including any other devices like ClickShare or PDS 4K yet, because yeah, we still want to keep some form of modularity. But we do have those packages available, and I think when we are sending out the answers, maybe we should also put out a link to the webpage where these packages are described. And you can also contact any of our sales reps who can give you a price list of these.
And I'll also make sure to do is in our recap email, we will provide a link to some of those prepackaged solutions for you guys to have a look at. Dion, do we have any more time, or is that we need to stop here?
You could probably knock out another question if he isn't too long-winded. I typically try not to go over more than 5 minutes or so. So if you want to knock out one more, go ahead.
Okay, let's see. I'm gonna. Does the process? Okay, I see a few questions are in chat as well. So, from Vincent, does the processor software allow for LED degradation when installing a new replacement module into a panel that has been in a substantial time, that has been in service for a substantial time? Do you want me to reread it?
I think I understand the question. So I think the question comes down to, can we in the software tweak the colors of the newly introduced panel to match the rest of the wall? I hope it's that I understand the question correctly, and this is possible. Yes.
Okay, great. So maybe one more. Does Barco have any solution to enable LED video wall to become touch interactive?
Yeah, we work with a third party for that, UTouch, and we are also looking in some other options where you even can do touch-free application, like you touch it, but you're not touching it, just because of COVID. But that's something that is currently not yet a solution. But like I said, for all those things, we work with third-party solution providers. So it's not something we develop ourselves.
Okay. How is HDR handled? That's the question.
HDR is handled in Infinipix. We can select the OTF curve for HDR10 and HLG. So PQ and HLG are selectable in the software, and the wider color gamut is automatically adjusted. And we always work at the maximum bit depth. So if the source is coming in at 10 bit or 12 bit, that's what will be shown. So that's really automatically.
Okay, so I think we still have quite a few open questions, around 10 open questions. What I will, like I mentioned, we will come back to you guys as long as we are, you guys have opted in to receive the recap email from us. We will come back with both the recorded version of the webinar as well as some additional information that we talked about, and answer all those unanswered questions. So you should be able to view those. Thanks a lot, we guys, for giving us the 5 extra minutes on top of an hour. Thank you so much, Sandra and Todd, and have a good day.
Thank you, Barco team. And I'd like to thank everyone for joining us on today's webinar, LED Video Wall Technology, a peek under the hood. The recording will be available on AVIXA's website at avixa.org/webinars within about 7 business days. And your half of renewal unit will be applied to those transcripts within those 7 days. If you have any trouble, please contact my team at webinars@avixa.org. And just a side note for CTS holders, if you've registered for the webinar with an email address other than the one that's on file for you, you actually won't get credit for attending. It'll need to get fixed on the back end. So email your account rep and tell them that you used the wrong email address when you registered, and then we'll get it taken care of you on the back end. I want to thank today's sponsor, Barco, and I'd like to thank our presenters, Alina and Sander, for helping us to understand what's under the hood of Videowalls. We hope you've enjoyed. Please stay safe and make it a great day, everyone.
Thank you. Bye.